Now, as we start topic 3 of chapter 5, we're going to look at some vocabulary to prepare us for some later lessons. For instance, what's a polynomial and what are polynomial functions? Now, in Objective 1, they want us to go over what is a term, and then we're going to look at the numerical coefficient, which we had in Chapter 2, and also can be abbreviated as just the coefficient. So, by definition, this is an expression. Now, if we put an equal sign there and something, that would be an equation. But just a series of terms, and terms are separated by either a positive sign or a negative sign. We worked on this in Chapter 2 also. So here there are 3 terms. Now, as we look at a term, part of the term is what we call the numerical coefficient. That is the number part that's associated with a variable. So, let's look at our list here. This is the term. What is the numerical coefficient? Well, it's just the number part. Now, if there is no number, then there's a 1 that's in front. We just don't write it. So the numerical coefficient of this would be a 1. And if there is no number but a negative sign, then the numerical coefficient is a negative 1. Negative 1 times z. So our numerical coefficient is negative 1. Now, when there is no variable, now you could think of that as being x to the 0 power, right? That would be a variable, but it only has the value of 1. So the numerical coefficient of a term all by itself would be just the number 2. Now, when we have something like this, where we have x to the 9th over 7, theoretically you could think of that as being 1 over 7. So the numerical coefficient is 1/7. Again, they don't usually write the 1 when it's an x, but the 1 is there. Now, what is a polynomial? Well, a polynomial is a series of terms. Here there are 2 terms. Here there are 3 terms. Now, what would be not a polynomial? Well, if the exponent on a variable is negative, that is, it would bring it to the denominator to have it be positive, then we say those type of expressions are not considered polynomials. So if it has a negative exponent, or if it has a variable in the denominator, then it's not considered a proper polynomial. But sometimes, that is a little mystery about why sometimes the authors of math books will say something's a polynomial, and then in other places they'll describe it as not. But this is the formal definition. Shouldn't have negative exponents on the variable, then it's not considered a polynomial. Now, when we write them, we often write them in what is called descending order. That we start with the highest power of our variable and then go down. This is descending. Okay? Now, we do have a couple of other words associated with polynomials, and that is those that have one term, and that's it. These are called monomials, with the prefix mono meaning one. If they have two terms, they're considered binomials, and if they have three terms, they're considered trinomials. But all of these are polynomials under the general umbrella, so to speak, and these are just three. Now we also have what is called degree of a term, and by definition the degree of a term is the sum of the exponents on the variables contained in the term. So if you had something like this, 5 to the second x squared y cubed z, this is all one term. Now here we would only be interested in the exponents on the variable, because this is actually 25, and we don't count the coefficient when we're defining degree of a term. So this variable has 2, this one has 3, and this one has 1. So the degree of this term we say would be 6. Now these, again, they want us to find the degree of each term. So here, only the exponents on the variable. This would be 2. Now this is the coefficient. We're not interested in that, just the variable. This would be 5. When there isn't 1 written, there's a 1 there, so this would be 1. Here this is 2 plus 1. Plus 3 is 6. Now here there is no variable, so we can think of it as x to the 0 in a way, but in a sense there is no variable there. So when there's no variable, we say the degree is 0. Now in this next definition, they're asking us to find the degree now of a polynomial, not a term. Now, the degree of a term is the sum of the exponents on the variables. Now, the degree of a polynomial, such as this, is the largest degree, the single largest degree of its terms. So I don't quite like the way they're saying this, but let's take a look at this example. So let's see if we can figure out the degree of this first term. Well, 3, 2, 1 is 6. So often when you're asked to find the degree of a polynomial, this is what I would do. Now this is 5, 6, 7, and this one is 3. So when you're asked to find the degree of a polynomial, and this is a trinomial, what is the largest degree of any one term? And you might say, well, it's 7. That's the degree of this polynomial. So we see it down here. Trinomial, this term is 3, this is 1, this is 0. So the degree of this polynomial is 3. Now, this is a monomial. There's only the one term, so it's 1 plus 1 plus 1, 3. Now, this one is 4. This is 0. So the degree of this polynomial is the largest degree of any one term, and that's 4. And before we leave this page, what is the error students often do when they're asked to find the degree of a polynomial? they'll add all of these up and get 16. And that's wrong. Remember, it's the degree of the largest of the terms within a polynomial. So write the degree of the individual terms and then pick out the largest. That's the degree of the polynomial. So as we see in example 3, this one is 2, this one is 4, this one is 2, this is 0. So what's the largest? 4. So the degree of this polynomial is 4. Now as we go on to objective 2, defining polynomial functions, well, here we have an expression. If we put the function symbol that we had earlier in front of that, then this becomes a polynomial function. Because now it's sort of an equation, and often recall we had values for x that we would substitute in that where we were dealing with function in chapter 3. And we want to remind you that when you see something in parentheses in the function notation, it does not mean multiplication. It's just part of function notation. So as we look at example 4, could raise it up a little bit. Again, what are they asking us to do? Well, we did things like this in chapter 3. So this was our function. P of x is such that 3x squared minus 2x minus 5. And we said sometimes we can use a little t-chart here. X and p of x. Remember, this is like a y here. And they want us to find where x is going to be a 1 and x is going to be a negative 2. So we take the 1, put it into our function, and it ends up being a negative 4. And then a negative 2 in there, carefully, being careful of the signs and doing what is in the order of operations, this will become 11. So again, we've done this before, and hopefully you can substitute, and we'll do some in our mini lecture. In example 5, they're giving us find the height of an object. Well, the world's highest bridge in France is this many feet above the river Tarn. An object is dropped from the top of this bridge. Neglecting air resistance, the height of the object at time t seconds is given by this polynomial function. That is, p of t equals a negative 16t squared plus this. Find the height of an object when t is 1 second and when it is 8 seconds. Well, for this, again, I would suggest a t-chart to help organize your data. We're going to put a t here, and this is p of t, but it's sort of like a y. We want 1 second and we want 8 seconds. And we're going to substitute the t right there. So 1 squared is 1, so this is a negative 16. You subtract 16 from that and you get your first. Then you square 8, it'll be negative 16. Squaring 8 is 64, plus 1, 11, 25, So using my trusty calculator, if I subtract 16 from this, I get 1109. And if I put an 8 for t squared, that gives me 64 times a negative 16 is this. And if I subtract this from that, I get 101. So again, here is a bridge over something that's very high up in the air, and we drop something. After 1 second, it'll be this height from the ground, and after 8 seconds it's going to be way down there. So it only has 101 feet to reach the ground. And on the next page, there's a picture of the bridge. Looks really up there. There's our first answer. There's our second answer. And again, the use of a T-chart helps to keep our data organized. I like that. All right. Now, one of the other skills that we're going to do is to combine like terms. And this is a review because we've done this before too. Now, what makes up a like term? Well, we said if the variable part of it was the same, including the exponent, these were like terms. If you had something like this, 3x squared y and 3xy squared, these would not be like terms, even though they have the same variables. In order to be like terms, the exponents on them have to be the same. And they're giving you a little illustration here. So what we're asked to do is, and I will show you what I think is a good strategy for combining like terms. Well, as we look at example 6, what are the like terms? Well, you could indicate them by maybe putting a little line underneath them. So these are like terms, and then this one and this one's a like term, and then this one and this one are like terms. Now, when we combine like terms, we only deal with the numerical coefficient part. So a strategy might be negative 12x squared and then a positive 7x squared. And then the other term is a negative 6x. And then what I've done is I've put them in like term columns. That's my helpful hint to you. So we're going to subtract the 7 from the 12, get a 5, x squared, and then the larger absolute value sign is negative, so this is a negative. And then we just bring this down, and that is our answer. Now here we could do it the same. 3xy. Another like term is 5xy. And then here we have a negative 2x. And here we have a negative, and you could put the 1 there even though it's not written, so it helps. So we're just going to add the numerical coefficients, 8xy minus 3x. 8xy minus 3x. That's my gift to you, in a sense. A technique to ensure correct answers. We'll be using that a little later, too. Now, the textbook features a horizontal approach. In a sense, you're putting things in parentheses, taking them out, but again, lighting them up horizontally. You could do that, too. But I still like the method that I showed, where you put 11x cubed going down, there's another x cubed, 1x cubed, then you have a negative 12x squared, and there is no x squared, but then we have an x, and here we have a negative 10x, here we have a negative 3, and there's a positive 5. So I like lining them up vertically, but you can do it horizontally as well. And then hopefully your accuracy is good. This will be 12x to the third minus 12x squared. Now here we have a negative 10 and a 1, so this is going to be a negative 9x. Here we have a negative 3 and a positive 2, 5. You end up with a positive 2. Okay? Now you get the same answers horizontally, vertically. I like this idea. And there in your homework log, you're listing your like terms. Good technique. Now, example 8 is very similar. Again, you want to put your like terms vertically. We'll have some practice of that in a little while. Okay, now when we are subtracting polynomials, and here they're just giving you a little background. We had some of this in chapter 1. If we had a minus b, well, this is subtraction. Now this can be modified to a plus a negative b. This is addition. So you see they're intimately related. Subtraction and then addition. So let's go on to work some subtraction. Now looking at example 9, how do we know this is subtraction? Well, because of this negative sign between this expression and this expression. Now there is a general rule. If you have an expression in a parentheses and there's no sign in front, we can just take these terms out of the parenthesis. But here's where you have to be super careful. If you have a negative sign in front of a parentheses, to be able to remove the parentheses, we're going to change this from subtraction to addition. And we do so by taking away the parentheses and then changing all these signs. This will become a positive, this will become a negative, and this one becomes a negative. And that's what they're showing you here. They've taken away the parentheses, changed all the signs, and now we've gone from a subtraction to an addition in some cases of unlike signs. But again, I still would use the technique of lining them up vertically. So we have 12z to the 5th. Any more 12z's to the 5th here? Nope. So then we have a plus 3c to the 4th. So I've done this one and I've done this one. Now I have a negative 12c to the 3rd. That's this one. And I have a negative 1z to the 3rd here. And then I have a z left there and a negative 12z. I probably should have done this down here. So now I'm just going to add up my terms. I have a 12z to the 5th plus 3z to the 4th. I have a negative 1, a negative 12. That'll be a negative 13z to the 3rd. And I have a positive 1z and a negative 12z. That'll give me a negative 11z. And, I had this here I wasn't able to write over that. So, but again, I think you're familiar with the strategy, or just line them up horizontally. But the key is, when you have a negative in front of a parenthesis, you remove the parenthesis, change all their signs, and then just add, combining signs that are unlike or like. Now, for example 10, at times you're going to be reading something. This says subtract from this. So, the key to something like this, when they say subtract, you're going to make all of these the opposite sign. 4x to the third, y to the second. This was a negative, now it's going to become a positive. 3x squared, y squared. This was a positive, now it's a negative 2y squared. Now this one, the one you're taking it from, doesn't change signs. You just have to put it in its like term column. So this is going to be a positive 10x cubed y squared. And this is a negative 7x squared y squared. And there's nothing there. So again, just put your line, and you only deal with the numerical coefficients. So this now is a 6x cubed y squared. Watching your signs, this will be a negative 4x squared y squared, and just bring this down. Negative 2y squared. And that should be it right there. Now the key is, when they say subtract, they've written out the word subtract. Just change all these signs and just add everything together that are like terms, being careful of the signs. Now here they are introducing the idea of doing it vertically. And you might see something like this. So there's a negative sign in front of a parenthesis. Remove the parenthesis and change all of these signs. What students often do, and it's in error, is just change the first one. You have to change them all. Okay. Now, one of the things we did a little bit earlier in, I believe it was chapter 3, and a little bit in 4, was we were dealing with function of cost function, revenue function, but now they're introducing profit function. And the formula for this is profit function, which makes sense, is equal to your revenue function minus your cost function. And that's what they have here. So they're giving you a revenue function, they're giving you a cost function, and we've put it into this form. There's our revenue, there's our cost. Now they're putting the cost function in a parenthesis, because as we subtract that, the 2, and we remove the parentheses here, this is going to be a negative 2x, and this is going to be a negative 5,000. Okay. So we subtract then negative 2x from 7x, get our 5x, and we have our negative 5,000. This is our profit function. Okay. Back in chapter 2, we talked about linear equations. These were straight line, or our values of the variable were only to the first power. But as we proceed, and in your next course, they're going to be talking about graphs of polynomial functions that are not linear, but we can identify them by the degree. So if you had something like this, I'll write it here big. The function of x is such that it's x squared. Now remember, we could put a y value there, substituting for the function symbol. And if we made a t-chart and put various points, we would find that when we put this and these values into a graph, it makes this sort of figure. This is a parabola. Now, this parabola is opening up upwards, and it opens upwards when, and I could put the letter A in front here, or if there's just a 1, if the A value, or the numerical coefficient of x squared, is positive, it opens upward. So we know just by looking at this one, it's a positive A, or our value, numerical value of x squared, is a positive. It's going to open upward. Now, if the value is negative, this would open up downward, and as we see it here. So, if the coefficient of x squared is a positive number, it opens upward. If it's a negative number, the coefficient of x squared, it opens downward. So, just some information. You want to have this in your notes. And some others, and I think we mentioned a little bit of this before. If you have the function of x is such that it's x to the third power, where you have a degree of 3, then this would be a typical one, and this would be a typical one, this would be a typical one, and this would be a typical one. So all of these shapes is if your equation were to the third degree. The exponent on the x was a 3. Okay? Now, if the x is a positive number, it's going to start low and go up. Now, it might swoop down here a little bit like this one, but it's coming from down this way initially. These are if your value of the coefficient of x to the third is positive. Now, if it's a negative number, then it's starting high on this end and ending up going down. Notice the difference. So again, just take some notes, do a quick sketch of these, and put them in your notes. So, determine which of the following graphs most closely resemble this one. Now, as we look at it, is our coefficient of x to the third positive or negative? It's positive. So, this is a parabola, so that's out. Now it starts this way and goes up this way. That is what the coefficient of x to the third is, positive. So it matches sort of this one. Now this one would be, again, x squared but negative. This is x squared but positive. And this one would say x to the third but negative. It's like these up here. Okay, so we're getting into some heavy stuff here. And we have spent probably enough time on this lesson. So we're getting ready to, if we had time, we'd go into the textbook and do some of this. But you're going to be doing very shortly your mini lecture on this, having some practice, and of course your study plan, practice, and quiz me's.